Sometime in the future, every neutrino detector on Earth will go off at the same time. Physicists in Japan, Italy, Canada, Antarctica, and the United States will see their instruments scream with a simultaneous flood of particles that shouldn't be there. Within minutes, the Supernova Early Warning System, a global network of detectors designed for exactly this moment, will send an automated alert to every major observatory on the planet. The message will be simple: a star has just collapsed, the light is coming, and we'll have roughly 1 hour before the sky changes forever. The star is Betelgeuse. You've seen it, even if you don't know its name. It's the bright reddish dot at the left shoulder of Orion, one of the most recognizable constellations in the night sky. For thousands of years, it's been a fixed point in human navigation, mythology, and astronomy. Aboriginal Australians may have even woven its brightness changes into their oral histories. But Betelgeuse is not a normal star. It's a red supergiant, 16 times the mass of our sun, and so swollen that its radius stretches between 640 and 760 times wider than the sun's. If you placed Betelgeuse at the center of our solar system, its surface would extend past the orbit of Jupiter. Mercury, Venus, Earth, Mars, and the entire asteroid belt would be inside the star. It's also dying, and when it finally goes, it will produce the most spectacular event any human being has ever witnessed. But how close is it to the end? That answer just changed. In late 2019, Betelgeuse did something that made astronomers around the world hold their breath. It dimmed. Not a little, it dropped from the 7th brightest star in the sky to below the 20th. The star that had reliably marked Orion's shoulder for all of human history was suddenly fading. Week by week, it grew fainter. By February 2020, it had lost more than 2/3 of its brightness. Professional astronomers scrambled to get telescope time. Amateur astronomers uploaded thousands of observations to global databases. Social media exploded with speculation. Was this it? Was Betelgeuse about to blow? News outlets ran headlines about the star's imminent death. The internet collectively panicked. It wasn't the end. Scientists later determined that the star had ejected a massive cloud of dust, a chunk of its own surface launched into space like a stellar sneeze that temporarily blocked its light from our line of sight. But the event revealed something important. Betelgeuse is unstable. It's pulsating irregularly, shedding material into space at an increasing rate, and behaving in ways that tell astronomers it's in the late stages of its life. The question has always been whether late means decades or millennia. In 2023, a paper rattled the astrophysics community. Researchers analyzing Betelgeuse's pulsation patterns and internal structure suggested the star might be burning carbon in its core, one of the final stages before collapse. Their estimate for the remaining lifespan was startling. Not hundreds of thousands of years, tens of years. The paper made headlines everywhere. Then in 2025, everything shifted again. A team at NASA's Ames Research Center, using the Gemini North Telescope in Hawaii, managed something astronomers had been trying to do for nearly a century. They directly imaged a tiny companion star orbiting Betelgeuse, hidden for decades in the red giant's overwhelming glare. They named it Siwarha, a Shoshone word meaning younger brother. Siwarha orbits Betelgeuse every 2,170 days, roughly 6 years. And its gravitational influence on Betelgeuse's outer atmosphere explains the mysterious long-period brightness cycle that had confused scientists for years. Here's why that matters. The 2023 paper based part of its tens of years estimate on those pulsation patterns. If the long-period variation wasn't caused by internal instability, but by an orbiting companion tugging on the star's atmosphere, the timeline stretches dramatically. Current estimates now sit at 100,000 years or more before Betelgeuse explodes. We're not watching a star about to die, we're watching a star that's terminally ill, but still has a long road ahead. And yet, when it does happen, whenever that is, here is what Earth will experience. The neutrinos come first. They escape the collapsing core instantly, passing through the star's outer layers as if they don't exist. Light, by contrast, has to fight its way out, absorbed and re-emitted billions of times. The neutrinos arrive at Earth roughly 1 hour before the first visible flash. Detectors worldwide will catch them. Alerts will fire. Astronomers will have 60 minutes to point every telescope, every satellite, every instrument on the planet at one spot in Orion's shoulder. And then the light arrives. Over the course of about a week, Betelgeuse will brighten to something between 1/4 and 1/2 the brightness of the full moon, all concentrated into a single point. Think about that. A star that normally appears as a faint reddish dot will suddenly blaze bright enough to cast shadows at night. Not diffuse moonlight shadows, sharp, hard-edged shadows from a point source, unlike anything you've seen. You could read a book by its light at midnight. During the day, it will be clearly visible in the sky, a brilliant new star hanging in the blue, bright enough that no amount of daylight drowns it out. One astronomer, Miguel Montarges, described it this way: "If you shut down all the lights in a city and had no clouds, you would be able to read by the light of the supernova. For weeks, possibly months, Earth will effectively have two bright objects in its night sky, the moon and a dying star. After about 3 months at peak brightness, it will slowly fade. It will remain visible to the naked eye at night for another year or two, and then Betelgeuse will be gone. Orion will permanently lose the red star at its shoulder. A constellation that has guided sailors, inspired poets, and anchored the winter sky for all of recorded history will look different forever. Is there any danger? This is where honesty matters. No. Betelgeuse is roughly 650 to 720 light-years from Earth. A supernova would need to be within about 50 light-years to pose a genuine radiation threat to life on the surface. At Betelgeuse's distance, the cosmic rays from the explosion would reach Earth, but would be far too diffuse to damage the ozone layer or affect human health. The neutrinos would pass through our bodies without a trace. We wouldn't feel a thing. But there would be consequences. Satellites in orbit could experience a temporary increase in radiation. The sudden appearance of a point of light nearly as bright as the moon could disrupt animal navigation systems. Migratory birds, sea turtles, insects, and other species that navigate by moonlight and starlight would suddenly have a second beacon in the sky they've never evolved to handle. Scientists have documented how artificial light pollution already disrupts migration patterns. A supernova bright enough to cast shadows would be unlike anything the natural world has encountered during the entire existence of most living species. And for astronomers, it would be the scientific event of multiple lifetimes. The last time a supernova was visible to the naked eye was in 1604, Kepler's supernova, over 400 years ago. The last one bright enough to leave a record in multiple civilizations was in 1054. Chinese and Japanese imperial astronomers tracked it nightly because they believed celestial events foretold the fate of empires. That explosion left behind the Crab Nebula, which we still study today. A Betelgeuse supernova, observed with modern neutrino detectors, gravitational wave observatories, and space-based telescopes, would generate more data about how massive stars die than everything we've collected in the history of astronomy combined. There's one more detail that doesn't get enough attention. Right now, the light we see from Betelgeuse left the star around the year 1300. The Middle Ages. Dante was writing the Divine Comedy. The Mongol Empire was at its peak. Everything we observe tonight, every brightness measurement, every pulsation cycle, every dust ejection happened 6.5 centuries ago. We're not watching Betelgeuse in real time, we're watching a recording. And for all we know, the star already exploded centuries ago. The collapse already happened. The shockwave already tore through the outer layers. The neutrinos are already on their way. There is no way to know until they arrive. Think about that the next time you look up at Orion on a winter night. The star at his shoulder might already be gone. And one day, maybe not in our lifetimes, but maybe tomorrow, the detectors will go off, the alerts will fire, and we'll have 1 hour to look up and watch a star die in real time. The last supernova visible from Earth was 422 years ago. Kepler saw it in 1604. Before that, Tycho Brahe saw one in 1572. Before that, Chinese astronomers recorded one in 1054 that was bright enough to see in daylight for 23 days. We're statistically overdue. When it happens, it won't be dangerous. But it will be the most extraordinary thing any living person has ever seen. A star that has burned for 10 million years will die in a flash of light that reaches across 600 light-years of empty space and lands on your face at midnight. And Orion will never look the same. Here's my question for you. If you had 1 hour of warning, what would you do? Would you watch it alone, or would you want everyone you know standing next to you? I think I know my answer. but I'd like to hear yours.